is Ethan, and I'm the main committer of the CI/CD SIG and maintainer of the QA SIG of the Open Euler community. And today I'm going to introduce you our CI/CD service, because most of you might use or learn that there is Jenkins or like Travis or GitHub Actions in the open source community. They are all famous CI/CD service, but all of them are not very adapted for our community, because most of our users they have different kinds of different kinds of requirements. Like some of them use embedded machine, or some of them use server, or some of them use OpenEuler or cloud, or just simple Docker. So for adapt for different kinds of architecture, bare metal, different kinds of operating systems. So we built our CI/CD service to satisfy our requirements. So that's our pipeline. The Comma CI is the base infrastructure of the of the OR pipeline. So I will start with the Comma CI first. It is the scheduling and executing system, which is the most important thing of any kind of complexity systems, like building or testing. All of them need the infrastructure to schedule resources or executing your job in the remote node. So let's start with the Comma CI. Comma CI is declarative. All the job of it you submit. All the job is declarative. You just need to submit a job YAML for announce the parameters you need, or the operating system, the kernel, or the text box node. All you need to just submit the YAML, and it supports different kinds of kernel, different kinds of machine, different kinds of software, all of them to serve your requirement for building or testing or benchmark, or just borrow simply to borrow a machine to use. That's what I'm talking about. That's just if you need a bare metal or a VM or a container, all of them are supported. And Comma CI is in microservice architecture and maximum of 16 containers. The picture of 3 layers is the 3 layers is all of the Comma CI, and the red one is others. I will introduce later. For the bottom one, the local run job layer is about some setup scripts, some monitor scripts, like the main info monitor, the CPU info monitor, etc. And the statistics script, and the run job script, which to run your task or builds program. The local run job layer will happen in each task box you borrow. And the middle layer is the remote run job layer, and it is about some service run in the remote manager node, like some life cycles, the mix scheduler, all the queries, all the database, and other service. And the red one, the project-specific pipeline will serve it is different kinds of application. So for different things, like if you need the building systems, and that is OLA Maker. So we build OLA Maker, our OS building systems based on Compass CI, and the OLA Maker is the extra service on the top of it. And the EulerPipeline I will introduce later. It is also a wrap layer application. The OLA Maker I will not introduce today because this is not my section, and it will be introduced in tomorrow 2:13 p.m. in room 202. If you have any interest of it, you could join the section tomorrow. So back to my session, I will continue for KHCN. Once the user submit the job YAML, the text box will grab it from the scheduler quiz. Once it grab it, it will use these 4 ways to prepare the environment needed for the job. Instead of installing, because we know if we install our operating system on the machine by the original way from like ISO or QEMU image, it will take a long time. But if we use the init run FS, we use the overlay FS way to make it. It will be very fast. To more specific, the init run FS means we will make all the components into one init FS file, and all of the system, of the software, the job need will totally run in memory. So it will be so fast when you deploy. And the NFS and CIFS means we will prepare init run this file for specific operating system, distro, and after we deploy the OS by mount the init mount the root FS. But it is reloading. We will then we will mount the overlay. We'll mount the readable layer by NFS or CIFS, so you could make your job happen on the overlay FS. So it will be very fast. But the top 3 ways have a shortcoming. That is, they could not persistently to store the data. So if you need to persistently store your data, you need to use the local display, which means the root FS will mount on your logical volume. So that is the 4 ways we support. So we don't do the install. So that's the way how Compass CI deploy. Error is inevitable. Every time we submit a job, and the job will, perhaps the job will offer different kinds of value. Like the picture on the left, the statistics show that there is several failures happen. So for Compass CI, the Compass CI will submit submit the git bisect tracing for each of it. For each of the error, Compass CI will find the first back commit for it. It will consistently submit the same job with different commit hash, and totally find the first batch commits for all the values. So it will make you easy to find out what is the root reason for the error. And for performance testing, use CompassCI, you could make a good comparison between two commits, two OS, or two hardware to find out what is the difference happened, what is the performance change, like the right picture show. That is the basic function of CompassCI, and now we here EulerPipeline, the CI/CD service. Because the basic function of CompassCI is how to schedule and execute job, but it could not make job and job run automatically. So EulerPipeline is to resolve this problem, to make a declarative grammar, to arrange all the stuff and divide them by event. So this is the architecture of the EulerPipeline. Is 1 plus 1 plus n plus n. It means one pipeline is under a certain declarative grammar, like the right picture, by several keywords, and it has n kinds of defined templates served for different scenes, which predefined by the maintainers, and all the templates arrange n kinds of autonomic jobs, such as building or testing, different kinds of scripts. Finally, the EulerPipeline will serve for kernel CI, so for package CI or distro CI, etc. About the declarative grammar, like this, it is very similar like the GitHub Actions one. If you need to define a webhook trigger, you could use the on keyword and announce what kinds of event you need, and Git repo, Ajax, branch, etc. Or you could also use on keyword to announce a cron tab trigger, which is the most used the interval, how much interval we need to trigger the whole workflow, and the structure of the control flow of the pipeline. You just use sequence and parallel sections, like the bottom picture show. All the red row is an announcement of her job, and the parallel and sequence will announce is represent the structure of the control flow. So it's no limit to announce how many jobs are parallel, or how complexly structured it is. Like some declarative grammar used in GitHub Action or others, they will basically they are limit the structure's complexity. So this kind of grammar just make it unlimited. So for the single rectangle, the red rectangle represents they are one atomic job. Like this is OneMaker create project job, and the job YAML is the YAML I mentioned before in the CompassCI section. So it is also declarative. The grammar also support the reference expression to embed in your YAML like this. You could just to reference value from the running context, like vars.os means this job while it's before it's submitted, it will reference the OS value from its context in vars namespace, or you could use this grammar to announce a Python expression to make some like string handling, or just make out numeric unique. And the matrix keyword is used to announce different kinds of combination. Like if you submit a job, but you need it run in different kinds of distro, different kinds of architecture to test it. You could just use this keyword to simply make your single workflow to split to many combination. And you could use overview of metrics in your website to simply glance how all the branch status is. And while your workflow, your pipeline occurs on arrows, like the job is value, you could click the button to reproduce the same environment easily. Once you click the button, we will provide the web terminal, which you could share with your partner to debug in the same web terminal, or you could just use your own terminal application to enter the environment for debug. And while you finish your debugging and make your pull request, update your Git repo, and the webhook email will trigger the new running record, and it will make a new turn of testing. The target for EulerPipeline is to support all the things of OPEC, like code CI means the access control on your repo, or kernel CI for the kernel repo access control, or the ISO CI, like how to build your own distro image. Like the release CI is for the release management for your community. So all of the CI title is for different kinds of things. They are all of them are different kinds of template. And like in code CI, the antivirus or the check SCA check license, they are all of them are atomic jobs supported by CI. So it means we could build a large ecosystem for different kinds of atomic jobs and use the template to arrange them easily. And all the thing you need to do to build your pipeline is to select or define template and make some fine tune, like set some parameters or change some little bit details, and your pipeline will work. That's all. And if you have any interest of the CI/CD system in the OpenOR community, you could engage us by these ways. And any questions? Thank you.